Welcome to the Ham Radio Nomad study session. And we are going to be doing this is the one I want. So we are going to be doing another study session today, going through the questions. I will probably do one more. I'll probably do study session this week, and then I will do a practice exam next week. So welcome all those who are watching. Please hit the like and subscribe button and see what, click the like button for this video, click the subscribe and notification button for my channel. I am striving to get 100 subscribers, because then I am big enough to be part of the YouTubers group, and also I can customize my channel name so I don't have a big ugly coded URL. I will be able to get youtube.com/hamradionomad. So please click to subscribe, and then click the notification so that you get notified when I go live. Currently I have 82 subscribers. It would be great to get to that 100 within the next couple weeks, if not sooner. So, and I am just, where do I need to go? That's where I want to go. And I am just verifying. You know what? I don't think I'm live. Nope. Okay. I am live, so that's good. Yeah. So now on to the study questions. There we go. First one, E5B3. How is impedance in polar form converted to an equivalent emittance? A, take the square root of the magnitude and add 180 degrees to the angle. B, take the reciprocal of the magnitude and change the sign of the angle. B, take the reciprocal of the angle and change the sign of the magnitude. D, square the magnitude and subtract 90 degrees. I'm going to go with take the square root of the magnitude and add 180 degrees. And that is incorrect. Okay, so it's take the reciprocal of the magnitude and change the sign of the angle. And yeah, if you want to pause the video, those that are watching on Team Replay, you can read the explanation for this. There isn't anything simple besides just memorizing it that for something simple to remember the the answer to it. So, which of the following parameters does a spectrum analyzer display on vertical and horizontal axis? A, SWR and frequency, um, B, SWR and time. I believe those are antenna analyzers, not spectrum analyzers. C, RF amplitude and frequency. D, RF amplitude and time. And I am going to go with uh, RF amplitude and frequency. Amplitude is in a spectrum analyzer, you'll see spikes for the signal, and then left and right, just like on the waterfall of W or of WST WSJTX. Left to right is the frequency. What is the definition of symbol rate in digital transmission? A, the number of characters carried per second by the station to station link. B, the number of control characters in a message packet. C, the duration of each bit in a message sent over the air. D, the rate at which the waveform changes to convey information. Um, this one would be, I believe it's going to be D. It is the only answer that actually they're talking about the symbol rate, and rate is also repeated in the answer. Which usually occurs if a Yagi antenna is designed solely for maximum forward gain. A, the front to back ratio increases. B, SWR is reduced. C, frequency response is widened over the whole frequency band. D, front to back ratio decreases. Um, for a Yagi, when you want forward gain, front to back ratio increases. And okay, it's it's backwards then. Okay. Um, there is a point of okay, that's why. There is a point of diminishing returns. So at a certain point, um, the the front to back ratio starts falling again. So okay. So that's you need to go to that point. Okay. Trick question there. What is indicated when one of the ellipses in an FSK crossed ellipse FSK crossed ellipse display suddenly disappears? A, selective fading has occurred. B, receiver has drifted 5K from the desired receive frequency. C, one of the signal filters is saturated. D, the mark and space signal have been inverted. Um, I don't know. I'm gonna guess. No, it is A. Selective fading. What is the relationship a between an AC current through the inductor and the voltage across the inductor? A, voltage leads current by 90 degrees. B, voltage and current are 180 degrees out of phase. C, voltage and current are in phase. D, current leads voltage by 180 degrees. And I'm going to, and the answer is A. The how I got this last time and how I remembered it this time is the voltage go, and I will tell you that do not, or if you want to yell at me, you can. I I need the comments to boost my video's popularity. So if you want to scream at me in the comments, I know this makes absolutely no. I am 90% sure this does not make electrical sense, but in my head, the voltage will go right across the inductor, but the current as it's going through the inductor slows down. So and takes longer to get through the inductor. So why that's how I remember this answer. And as I said, electrically, I am pretty sure that I'm wrong in the theory of it, but it's how I remember it's how the things I'm doing to remember it in my head. Um, what is tri-state logic? A, proprietary logic devices manufactured by tri-state devices. B, logic devices that utilize trinary math. B, low power logic devices designed to operate at 3 volts. D, logic devices with 0, 1, and high impedance output states. So I know it's not B and C, or sorry, A and C. The question is it trinary math, or I'm going to go with D. Yep. Logic devices with 0 or 1, 0, 1, and high impedance. So someone else said, I like to think of it as 0, 0, fault, 0, 1, and null. So in programming, that would be a true, false, or a null, or empty value. What is the purpose of the preselector in a communications receiver? A, to provide a range of AGC time constants. B, to increase rejection of signals outside the desired band. C, to allow selection of optimal RF amplifier device, of the optimal RF amplifier device. D, to store often used frequencies. Oh, what is the purpose of a preselector? I'm going to go with B. Yep. Increase rejection of signals outside the desired band. On what frequencies are spread spectrum transmissions permitted? only amateur frequencies above 144, only amateur frequencies above 50, only amateur frequencies above 222, D, only amateur frequencies above 420. And I picked A last time, and so I remember getting it wrong, and it is 220. So I believe that would be the 125 meter band and up. What is a common method of generating SSB signals using a digital signal processor? I remember I got this long last time. Let's see if I can remember the right answer this time. A, mixing products are converted to voltages and subtracted by adder circuits. B, varying quartz crystal characteristics emulated in digital form. C, frequency synthesizer removes the unwanted sidebands. D, signals are combined by a quadrature phase relationship. I'm going to guess D. Okay. This is SSB is the mathematical form of quadrature amplitude modulation. E8B3. What is the modulation index of an FM phone signal having maximum frequency deviation of 300 hertz either side of the carrier frequency when the modulating frequency is 1,000 hertz? So deviation of 3,000, carrier frequency of 1,000. Okay. So that's a simple one. It's just deviation divided by the modulation frequency. On the Smith chart shown in figure 9-3, what is the straight line shown above? A, the reactance axis, B, the current axis, C, the voltage axis, D, the resistance axis. So I'm going to go with D this time. Since last time, Smith's chart, I believe, shows the reactant and the resistance. So I know B and C are wrong. Last time I picked reactance and I got it wrong. So this time I picked resistance. What is the National Radio Quiet Zone? A, an area in Puerto Rico surrounded by I don't know how to pronounce that, radio telescope. B, area surrounding the National Radio Astronomy Observatory. C, an area in New Mexico. D, an area in Florida. I'm going to go with B because I believe it is in West Virginia. And there is no other answers. None of the other answers are West Virginia. What is the power factor of an RL circuit having 60 degrees phase angle between the voltage and the current? And I believe, get my calculator here a minute. And if I don't get caught up in my uh, microphone cables, I believe it is cosine. The power factor is cosine of the, so we have 60 degrees and we want the cosine of that. And so I'm going to guess C. Yep. The power factor of an RL circuit is the cosine of the angle. Which of the following factors most affects the accuracy of a frequency counter? A, input attenuator accuracy, B, time-based accuracy, C, temperature coefficient of the logic, D, decay divider accuracy. I'm going to guess B. I think I'm just most of this is I'm just remembering these from going through from all the times I've gone through these. Hey Andy, thanks for watching. Um, when you where you're where in what context? I don't understand what the question is. What is the most common type of photovoltaic cell used for electrical power generation? A, copper oxide, B, cad- cadmium, cadmium sulfide, C, silicon, D, selenium. And the silicon is what the solar cells are typically made of in solar panels. What is the most common configuration of a opto isolator or a opto coupler? A, an amplitude modulated helium an amplitude modulated helium neon laser. B, frequency modulation, a frequency modulated helium neon laser. C, LED and photo transistor. D, a lens and a photo multiplier. Uh, I'm going to go with C. More of just because, yeah, lasers, not so much. Um, it doesn't have much to do with, lasers don't have much to do with, this feature is found in some high frequency transceivers that use transfer electrical signals between isolated circuits using light. Which of the following filters would be the best choice for use in a 2-meter band repeater duplexer? A, an LC filter, B, a BSP filter, C, a crystal filter, A or D, cavity filter. I'm going to guess A. Nope. Uh, cavity filter. Okay. It is a cavity filter is the best choice because it has a very high Q and can handle high power. Why should phase shifting of PSK signal be done at zero crossing of the RF signal? A, to simplify modulation. B, all these choices are correct. C, to minimize bandwidth. D, to improve carrier suppression. I'm going to guess all these answers are correct. Nope. To minimize bandwidth. Triggering a signal at a non-zero crossing is an instantaneous shift, locally similar to a square wave. What describes a pi Pi L network used for matching a vacuum tube final amplifier to a 50 ohm unbalanced output? A pi network with an additional series of inductors on the output. B, a matching network in which all components are isolated from ground. C, a phase inverter load network. D, a network with only 3 discrete parts. Um, it's so I pick going with A. It's the only one that is also refers to pi network. So it talks about a pi network. So that's also in the answer. Which of the following component packages types would be most suitable for use in frequencies above the HF range? A, TO-220, B, surface mount, C, radial lead, D, axial lead. I'm going to guess surface mount just because above HF gets into VHF and you do like surface mount vehicle stuff, surface mount vehicle antennas. And I completely wrong, um, completely wrong electrical or what they're referring to. They're referring to surface mount electrical components. Um, and there is a similar question with uh, integrated chips, that why do integrated chips not have legs on them in the UHF spectrum? And that is because you have the legs can, when you start getting into the microwave range, the legs can actually start becoming resonant. So this is a similar thing, um, that another reason for surface mounted devices is that you have uh, um, things can start at the higher frequencies, things can start have capacitive and inductive reactance. What is the modulation index of an FM signal? A, the bandwidth of the transmitted signal divided by the modulating signal frequency. B, the type of modulation used by the transmitter. C, the ratio of the frequency deviation to the modulating signal frequency. D, ratio of the modulating signal to the amplitude. The ratio of the modulating signal amplitude to the frequency deviation. So I believe we had this earlier, um, and unlike the test, if I was having these questions in the test, I could actually go back to that question and look at it, which is one reason why you don't actually get the answers till you're all the way through, is because you can actually, questions later may give you uh, insight on other questions that you've had. It is either C or D, and um, I'm going to say no. I got it wrong. The ratio of the frequency is on top, and the modulating frequency is on the bottom. What is the bandwidth of 170 hertz shift and uh, 70 170 hertz shift, 300 ASCII baud ASCII transmission? A, point 0.1 point 0.1 hertz, B, 0.3 hertz, C, 0.5 hertz, D, 1 hertz. Okay, B, so B through D are kilohertz, and A is a hertz. And I'm going to guess C. Yep. The reason I guess C is because yeah, the reason I guess C is because I believe, let me see this. Uh, I believe WSJTX is, and I don't have that up. Nope. Yeah. The reason, so, and it looks like my logic of why I thought why I picked it was wrong, but I did point 0.5 because WSJTX is in that same 50 to 500 right. I believe it's 50 hertz is the width of WSGTX, where this answer was 500 hertz, but it's still that 50 that made me think of it. So, what does the radio communication term ray tracing describe? A, modeling a radio wave's path through the ionosphere. B, evaluating high voltage sources for X-rays. C, determining the radiation pattern from array of antennas. B, the process in which an electric display presents a pattern. I'm going to guess C. So I was wrong. It is modeling a radio wave's path through the ionosphere. Which of the following is a property of a T network with series capacitors and a parallel shunt inductor? A high pass filter. B, a band pass filter. C, a low pass filter. D, a notch filter. Um, I do not know. Um, I'm gonna guess band pass. I'm gonna guess band pass filter. Nope. It is a high pass filter. What letter is commonly used to represent susceptance? A X, B Y, C G, D B. I don't know what the answer is, but I'm going to guess C for G, just because susceptance is allowing things to go through. So I'm going to pick G. Nope, it is B. So it is. So if you want to, for those watching on Team Replay, if you want to just take a look and look at all these terms, we have susceptance is B, which is a reciprocal of reactance, which is X. Conductance is G, which is a reciprocal of resistance R. Admittance is Y, which is a reciprocal of impedance Z. Elastance is S, which is a reciprocal of capacitance. Reluctance, and I don't know what that letter is a reciprocal of inductance. And yeah, they have a thing, and I don't exactly get it. Um, B is the only one that is susceptible of being an answer. Um, when I looked at it, it's like it's it's out of place because B should actually be on B. But yeah, what advantages surface mount technology offer at RF compared to using through-hole components? A. Shorter circuit board traces. B. Components have less parasitic inductance and capacitance. C. All these choices are correct. D. Smaller circuit area. I'm going to guess B just because of the other one where they talked about surface mounts, um, that at the VHF and higher frequencies that the other ones could have inductance and reactance. And it is actually all these choices are correct. What is considered an acceptable maximum IMD level for idling PSK signal? A plus 10 dB, B minus 20 dB, C minus 30 dB, D plus 15 dB. I'm going to guess, probably wrong, but I'm going to guess negative 3 dB, just you want the least amount of signal for idle. And I was right, probably for the wrong reason. Yeah. IMD is intermodulation distortion. And you want the lowest amount of distortion as possible. What is the radiation pattern? What is the radiation pattern of two quarter wavelength vertical antennas spaced half wavelength apart and fed 180 degrees out of phase? A, choroidal. B, a figure eight broadside to the axis of the array. C, omnidirectional. D, figure eight oriented along the axis of the array. So let's see if I can think my way through this. I don't know. I'm going to go B or D, and it's right. So here is this link here is what talks about all the shifting with the different antennas. So if they're half wavelength, if they're in phase, so here's the example of polar radiating power from two antennas spaced a quarter wave apart. So, which is sort of like a, I don't know, oblong. But this would be, I believe it would be considered omnidirectional. If you increase the wavelength to half a wavelength apart and they are in phase, then you get a figure eight. Then you get a figure eight broadside to the So that's that website there. Um, it you can go there for more detailed of all the different options and how the phasing uh, applies to each other. What materials are commonly used as a core for in an inductor? C. Cobalt and aluminum. B. Polystyrene and polyethylene. C. Teflon and Delrin. D. Ferrite and brass. I'm going to go with ferrite and brass. What is receiving directivity factor? A. Relative directivity compared to a dipole. B. Relative directivity compared to isotropic. C. Forward gain compared to average gain over the entire hemisphere. D. Forward gain compared to the gain in the reverse direction. I'm going to go with B. Nope. It is I was wrong. It is C, forward gain compared to the average gain over the entire hemisphere. Which of the following limits the highest frequency signal that can be accurately displayed on a digital oscilloscope? A, all these choices are correct. B, the amount of memory. C, the Q of the circuit. D, the sampling rate of the analog to digital converter. I'm going to go with D. Yep. If the sampling rate is not fast enough, it cannot pick up the dips and the changes in the frequency. What third family of circles is often added to the Smith chart during the process of solving problems? A, the standing wave ratio circles. B, the antenna length circles. C, the coaxial length circles. D, the radiation pattern circles. Um, I'm going to guess A because the standing wave ratio, because that is what we typically use. That is what we typically are reading when we're looking at Smith charts for with antennas. At least the entry level people are. Now I figure and assume especially with a network analyzer like the um, Nano VNA, it can do a lot of things more than just SWR, but that's what we typically use it for. And that is correct. So I am going to leave on a high note with a correct answer. So 73 to all. Unfortunately, I do not believe Ham Radio 2.0 and or Tank Radio are doing a live broadcast tonight. They are taking the night off for Mother's Day. So I am going to say 73 to all. And until we talk again, um, practice your FT8 off. Join me in the last chance practice Thursday at 4 p.m. Central. And and we can see about practicing some digital modes. So take care. 73.